Welcome to this session, this build session. Hope you've had a great build so far and enjoying the sessions. This session here is a Learn Live session, and it's called Get Started with AI on Azure. There's a link there which you can follow along, but my suggestion is you actually just kind of follow on the presentation and check out the content after. Anyway, so welcome and thanks for taking the time to join us today. My name is Dave Glover. I'm a cloud developer advocate. I'm actually based here in Sydney, Australia at Microsoft, and I work in the AI team, and the AI advocacy team. Okay, secondly, it's a great pleasure to introduce Priyanka. Priyanka is a Microsoft MVP. She's based in Singapore and is a group manager at Avanade. So Priyanka, would you like to quickly introduce yourself?
Yeah, thank you, Dave, and welcome all. This is Priyanka, and as Dave mentioned, I'm a MVP for AI. I lead the AI IoT offerings out of Southeast Asia for my company, Avanade, and great to have you all here.
Great, thank you so much. Now you can also follow us, so feel free to connect to us on LinkedIn. I'm Gloveboxes on LinkedIn. Some of the demos that you're going to be seeing today are also on my GitHub, and not by coincidence, that's also Gloveboxes. So just go search for Gloveboxes on GitHub. And you can also follow Priyanka on ComputerWhiz PyYU. Okay. So as I mentioned, there is this is the module here. So, but the recommendation is you really just follow along on the presentation and go and check it out. But the module that we're going to be talking about is a very well-rated module. You can see over 50,000 people have done this module, and it's actually pretty straightforward to go through. And it's a great way, if you've not done any work with AI before, then it's a great place to start. Now, questions. Feel free to ask questions from you're using. So please feel to just introduce yourself, maybe tell us where you're from. If you do have any questions, then feel free to ask questions. Now, we do have some fantastic moderators. We actually got 4 moderators for this session. I'm thanking them. So we've got Corey, Alicia, Diana, and Ryan, who are there to begin answering the questions. And in an ideal world, if there are questions that make sense for us to answer as we're talking, then we'll also try and address those questions as we go. So the main thing is, do feel free to ask questions. The session is live, and we will do our utmost to answer those questions. Okay, so we're going to talk about the learning objectives for this session. So we're going to be learning about different kinds of solutions for AI that AI make possible. And we're also going to talk about the considerations for responsible AI. So basically 2 areas. What can you do with AI? And we're also going to talk about responsible AI. Okay, so we're going to have an introduction to AI. Now, I'd say that this is an introductory session. So if you have been playing around with AI forever and Azure AI, this is probably not the session for you. But if you're kind of new to this world, then this is the perfect place for you. So what is AI? So AI is basically software that imitates human behaviors or capabilities or intelligence. That's fundamentally what it is. It's a branch of computer science. Where they build models, people talk about building these models and things like that, and we're going to talk a bit about that. And AI can be used in a wide range of places, and no doubt you're already doing this, but you can use it to improve your productivity. We're also already starting to see some of the AI flowing across into things like Office, things like healthcare, using AI to better understand maybe the outcomes or people, or be able to scan cells, for example, to be able to look for cancer cells or things like that. So AI has a huge opportunity to improve our healthcare. Being able to detect things like credit card fraud. Now, I suspect we've all either been impacted by credit card fraud, or we have friends or family. And AI is a fantastic way of being able to deal with or try and deal with credit card fraud at scale, improving customer service, providing better access to information about our products and things like that, but also things like overcoming physical disadvantages. So for example, for vision impaired people, you can start using AI, for example, doing text to speech is a great example where you can be using AI to improve people's lives. Okay, so as I said, this session here is about getting started with Azure AI, and we're going to be covering off about 3 different areas. So the first area, in fact, this is going to be covered by Priyanka, is we're going to be looking at machine learning services that we support in Azure. And this is specifically for, or really for, the data scientists or machine learning engineers. And the product category this comes under is something called machine learning, Azure machine learning. Now, the next thing we're going to talk about is something called cognitive services. Now, cognitive services are predominantly for developers, for application developers. So the beauty of these cognitive services is that you don't need to be a machine learning engineer to be able to implement AI into your applications. So the idea is you've got these services and then you can call into these services and then get responses back from them. And these are some of the quite popular ones. In fact, these are the ones we're going to talk about in these sessions, but we've got something called Anomaly Detection. We've got various vision services, which will go into more detail. We've got natural language processing, which is also referred to as NLP, if you hear that acronym. And we're going to talk about knowledge mining. Now, before I move on, I just want to make one point about these. These cognitive services, predominantly you will call them from cloud-based. So you'll make calls up to these cloud services for cognitive services. Now, that is not the only way that you can run cognitive services. So for example, there are a number of services that you can deploy on premise in containers. And you might want to do that for governance reasons or privacy reasons, things like that. So just as a bit of an aside. Okay, and the last area that we're going to talk about is something called responsible AI. And we're going to talk about some guiding principles and tools to make sure that when we're building AI systems, that we're thinking about the broader impact that these applications that use AI can have. Okay, so without further ado, we're going to hand over to Priyanka, and Priyanka is going to talk us through machine learning.
All right. Thank you, Dave. And that was really interesting to know about the what of AI. But then how do we do AI, right? How do we get started with AI? So that is done by using something which we call as machine learning. Machine learning is basically the heart of AI. And what does machine learning do is basically, you give a set of data points to the machine, you teach it, and then basis the training which you give the machine, it will be able to find relationships in the data. So on the screen here, let's say you have some data points in the form of flowers, right? And each flower has a feature like number of petals and the size of the stem, color, right? And then you're labeling the data. So you're labeling the data as tulipa or rosa or Bellis perennis. And then you will be teaching the machine that these are the salient features of the data, and this is how you're identifying each particular data point. And then once the machine is trained, right, so your wheels are churning, and now once you show an unknown data point to the machine, it will be able to predict, right? So this is what is called as machine learning. You help build the models and then train them, and then the trained models are then used for inferencing purposes. Make sense, Dave? And then we will talk about something which most of the time, most often than not, will come across regression, which is the most common type of machine learning out there, right? So regression, what we would do is typically take a series of historic data points given to us and then try to establish a relationship between them. So here you see on the left-hand side column, you have data points pertaining to weather conditions, right? So humidity, temperature. And then the second column talks about the number of bike rentals. So let's say if the temperature is around 56°F, then the number of bike rentals are around 115, right? So given these data points at a futuristic state, what would be the number of bike rentals, right? So these are the two variables you have, and then you're plotting those, you're trying to establish a relationship between these two variables, what we call it as approximation of using a function. And then you will divide your data set into two, training and validation. The training part is actually used to establish this nice line you've got through your data points and arrive at a function, right? And the validation data and is then used to test this function, right? And make predictions for the future. So now if you see that, the valid function which you've gotten, if you're now using it to make predictions, can you just click Dave once? Yeah. So as you can see in the validation, the function is making certain predictions, and how far off it is from the actual data, that will tell you the accuracy of your model, right? So as you can see the data on the screen, our function did quite a good approximation of the relationship between these two variables. Next slide. Dave, you're on mute. Dave, you're on mute.
Thank you for that. Just to reiterate that, and I'm glad I paid attention at school when I was doing my algebra. So we've got a data set. In this case, we've got temperature. What's the temperature of the day? We've got how many bike rentals. We're going to feed that data into Azure Machine Learning, yes. And then we're going to Machine Learning is going to generate an algorithm for us, and then we're going to use that algorithm to replay that and say, okay, well, on this day, if I've had 62, if the temperature is 62, I expect there will be what is it? 128.
Yes, around 128. That's right. That's right. That's right. Yep. So yeah, this is the function which you've gotten, and the little far off data predictions which you've made, right? So let's say on a given day when the temperature was 54, the bike rentals were 114, but we predicted 116. Those small off points are what we call as biases or errors, right? And then those will actually we will fix to get the model accuracy or fix the model accuracy. Yeah, but those are things which we would discuss at a later point of time in a bit of deep dive. So let's move on to the next slide. Okay, so now that we've talked of how machine learning works, right? And there are various type of machine learning algorithms out there. Let us look at Azure machine learning, right? So it's a cloud-based platform for machine learning. It takes basically all the hard work out of, you creating, bringing your own models, right? So it gives you all the services packaged as cloud platform. So you have your Azure subscription, then you will have your Azure machine learning workspace here. Inside the Azure machine learning workspace would be all your compute, your CPUs, your GPUs to run your machine learning, your data, your experiments, your models, and finally the services which you would expose it out to the end users to consume your machine learning models and get inferences and use them inside their applications. Okay. Now, for designers out there, there are variety of ways of creating and using Azure machine learning. So one of the ways is also using Azure Machine Learning Designer. It gives you a designer interface where you can drag and drop boxes, right? So you can choose your data sets, you can choose the kind of models you want, the transformations, the scoring methodologies, evaluation methodologies. So this kind of, gives you a UI UX interface to build your models and then, create machine learning pipelines. It's one of the ways, of course, there will be limited functionalities inside here, but nonetheless, it's a good way for beginners to actually get onboarded onto the AI journey.
Yeah, and what I tend to find, because I'm an application developer, I found that this is a great place, a great playground almost, to start playing around with ideas. It's much more drag and drop. You can start learning about, okay, what's the implication of this? How do we go and split data? The machine learning service, I think, was kind of like a stage further. You're probably a bit more advanced in terms of your requirements and things like that. Yeah.
Exactly. And then we go a bit further where we talk of Azure automated machine learning. So let's say for most of the run-of-the-mill scenarios, like, the regression we talked about, or you will have a very standard classification clustering methodologies to be used. So in that case, instead of, writing all the code and, doing the same thing again and again, why don't we just make use of automated machine learning? So you just need to bring in your data. You need to know what are your variables, what is the label you want to predict. That's all you need to know. And then you offload all the smart work out there to the AI to let it decide what kind of regression it is going to choose for you, what kind of features it is going to choose for you.
Okay.
And then finally you get the model, right? So all the compute and model selection, algorithm selection is all done out there by the automated machine learning.
Okay, cool. As I like to say, it's almost like using AI to go and generate AI. It's kind of the way it works. Okay, thank you, Priyanka, for giving us a bit of an overview of some of the machine learning services. Now, as Priyanka said, the machine learning services, they're kind of fundamental services. You go and use them to go and build models. So as I said, this section now is going to be much more about cognitive services. And these are services that I, as an application developer, can go and use without having to be a machine learning expert. So the first thing I want to talk about, or the first service I want to talk about, is something called Anomaly Detection. And there are a wide range of scenarios for anomaly detection. A really great example is things like predictive maintenance. Be able to figure out, I don't know, maybe you've got a piece of machinery in a factory, or maybe there's an air conditioning system in your building, and being able to figure out what is the likelihood of that machine failing. And in which case, if you think it's going to fail, then you can get on top of it and you can fix something before it becomes a major problem. As I mentioned before, credit card fraud detection is another great example. And one that's very popular is looking at business and accounting anomalies, or looking at metrics. So for example, you might want to feed your current sales figures into anomaly detection, and then find out, is there something that's happening across my business that maybe is out of whack, that maybe is some unexpected, or maybe my revenues are not, or my returns, etc., are not what I'm expecting. Things like IT ops. So maybe you want to be looking at, are there some unexpected patterns of access against my website or across my network, and be able to look at things like that. Now, also, you can also look at more complex systems. So for example, like an oil rig. Now imagine like an oil rig is like an ecosystem in its own right. And there are lots of correlated aspects on an oil rig, that one aspect of an oil rig might have a knock-on impact to another part of an oil rig. Or think about buildings, office buildings, air conditioning systems, being able to understand what are the patterns. Maybe an air conditioning system has broken down in the building, and now suddenly you're seeing people not using that space, or maybe the temperature's too high, or things like that. And obviously the same would apply for factories. Now, there are two types of anomaly detection that I'm going to talk about. In fact, there are two types that are supported. The first type is something called univariate. And almost by definition, by the name, univariate is there for tracking a single metric. So for example, you could track temperature, or you could track revenue, or you could go and track network or website activity. So you can use it. Now, the beauty of univariate is it automatically selects the appropriate AI model as the data is being fed through. You can either stream that data through, or you can batch load that data up into univariate. And the other advantage is that no training is required. So it makes it very straightforward to go and use. But again, it's a simpler use case. Now, we also have this thing called multivariate. And multivariate is more for complex systems. So again, I mentioned the oil rig before, and you could be up to 300 different correlated metrics. So it could be metrics that you're getting from sensors across your building. It could be metrics across your business, factories, oil rigs, or airplanes, or whatever it might be. And you can use that to look at and find anomalies in much more complex systems. Now, for multivariate, you require training, and you do require training data. So you need some historic data to say, okay, this is a steady state of the system. We need to train it with a steady state, and then the system will be able to figure out, okay, there is, and then you basically train up with that data, and then you start feeding that system data with real-time data, and anything that's outside of that steady state will then throw up an anomaly. So that's kind of how that works. And I've got a very simple demo that I'm just going to pop to. This is a predictive maintenance demo. Now you'll find this predictive maintenance demo up on my GitHub. So remember I said it was up on Glove Boxes is my repo. And there's a very simple, a fairly straightforward example there of collecting data. And this happens to be collecting data for an air conditioning system. And you can see there's a device that I built and things like that. So what I've done with that is that was actually collected data. And I've got the data over here, which is known as time series data. So this is the data that came from running that system. And you can see I ran it back in 2000. This data here was 2002, 2022. And you can see there's a timestamp and a value, and that is as simple as a data format would be. So let's say you were looking at revenue. The value would just be the revenue. In this case here, the value is the temperature. And you can see, just looking through this as a human, we can see, there's interesting to see that there are some spikes on there. But there's a lot of data in here, and it obviously wouldn't make sense to go through this manually. So what I'm going to do is I've got what's called a Jupyter notebook in here, and this I'm going to be able to do some analysis. So what I'm going to do is load up that data into the Jupyter notebook, and we'll just scroll down, and you can see that there goes the data that's been loaded up that I just showed you a moment ago.
Yeah.
And we'll just scroll down through here. And you can see what I've got here is a chart. And this chart here is showing you, okay, you can see the steady state temperature that I'd be expecting. You can see this line over here. But you'll also see in this graph here, there are some spikes. And those you can see have been labeled as anomalies. Now, this is obviously a very good visual way, and you can change the sensitivity of these things. So what's happened is that this data has been sent to the anomaly service, and then I've got back the data, said, okay, well, these data points are anomalies. So you're going to say something, Priyanka?
No.
Okay, cool.
Nice.
And so these are anomalies. So you can see this visually. Now normally in a business, like in a business system, you would integrate this data into a back-end process somehow. Maybe they would have a system there to go and notify the maintenance department to say, hey, look, you need to go and look at the air conditioning system. But certainly for visualization, this is a great way in which you can see what's going on. Okay, so that's anomaly detector. Okay, so the next thing I want to talk about is vision services that are provided within Azure. So there are a number of services. So what are vision services? Well, vision services are AI for visual processing. And there are a lot of scenarios. There could be things like image classification. And if you look through that learning module, you'll see there's a great example there of using image classification. They've trained up models to recognize taxis, buses, cars, and things like that. So that would be a great example there. Object detection is another scenario where you might want to figure out, is there something that's on a building site that shouldn't be there after hours? Or maybe people aren't wearing or taking the appropriate safety precautions for this particular machine that's on this building site. People counting is another very popular. You want to understand how many people are in your retail outlet, for example, or in your office space. So do I need to turn can I turn the air conditioning down because there aren't that many people in this office space? Retail checkout. So in Australia, we have self-service checkout. And nowadays we have cameras which look at the produce that we're putting onto the scales. And it will take a predictive approach to thinking or looking at what's on the scales and say, okay, this person is scanning bananas. And it will come up and it will prompt and will suggest, well, bananas is what I think it is, what I think you're scanning. And obviously that streamlines the process. Things like optical character recognition, being able to determine what text and extract text from forms. So those are kind of scenarios, but there are obviously lots of different scenarios. Now, the Azure Vision Services kind of come under three main categories. There is something called computer vision. And computer vision has a number of services in there. One has been optical character recognition. We've got image analysis. We've got face APIs, and we've got spatial analysis. So things that are spatial, super useful for people counting. I'm going to touch on Face API. Now, Face API is actually an interesting one because and I'm going to talk about responsible AI later, but not all services are immediately available, or they may be available in more limited scope. So, for example, the Face APIs, we do not sell to the US police enforcement because we are concerned of the way in which Face APIs can be used. If you're going to use just detection, you just want to be able to detect, is this a face or not a face? That's generally pretty available. But if you want to say, is this a certain person's face? Then you need to be signing forms, responsible AI forms to say, this is my intended use case. So we're very wary about how some of these systems will be used. So just keep that in mind, that not all APIs have immediate access, but you just need to fill in what the scenario is and things like that. We have another service called Custom Vision Service, which is an amazing service that can be used for a whole range of examples, whole range of scenarios. I'm going to show a very simple retail example in a moment. And we've got something called Form Recognizer. Now, in today's world of everything being on the web, of course, we all know that paper forms still exist in our business processes. Here in Australia, every time we had to go and have a COVID jab, we had to go and fill in a form, and then suddenly that form had to be loaded up. So with Form Recognizer, it provides a great way of extracting data of forms. So what I'm going to do now is just show a couple of examples of some of these. I'm going to show something called Vision Studio. Now, Vision Studio is kind of like the backing studio for computer vision. And so I've gone into Vision Studio. You can sign into this yourself. And this is you can see some great examples. So for example, here, I want to extract some data of a form. And you can see I've dragged and dropped that, and we've loaded in an image. And you can see that this is the data that's come off this form. And if I go and look at the JSON for this, you can see, oh, that's interesting. They've got what's called bounding boxes. So where's the location on this form? And you can see the kind of data in there. If I go to a couple of other ones, there's nice background removals. But, excuse me, the one I really liked is a spatial analysis. And so things like people counting. Now, this is a video, and you'll see what we've got. We've got what's called a polygon, and the polygon here defines the area that I'm interested in. But you can see that we've got a real-time camera feeding into this. Now, clearly, this is a recording, but you'll get the general idea that we've got no identified information, but we can say, okay, this is a person. And this might be super useful for understanding shoppers' behaviors and things like that. It can be the kind of scenarios for that. Not that we're doing this quite so much, but yeah. So during the pandemic, of course, we were interested in social distancing. And you can see that we can work out social distancing and kind of that. But fortunately, I think for most of us, we're kind of past that. So those are some of the interesting scenarios you can go and do with that. Okay, so Vision Studio is predominantly around support for Azure Computer Vision as a service. Yep. Now, the next thing I want to talk about is something called Custom Vision. Now, Custom Vision is a fun one to play around with and to kind of get some concepts. And I love this because you don't need to know anything about machine learning. You just have the hardest thing about this project is actually collecting the images. And you can see I've got a whole stack of images of fruit. And you can imagine this is the retail. In fact, the original idea behind this, or the idea behind this, was retail for vision impaired people.
Yes.
And the idea being is you'd hold the produce under a camera, and then the AI would come back and say, you have scanned in some grapes. So what we've got over here is that I've got a whole lot of fruit, and you can see what I've done is I've loaded up these images and I've labeled them. And if you look over on the left-hand side, you said these are bananas. And if I come over here, you can see I've got green apples. Now you might be wondering why I've got hand. And this I discovered every time you put your hand under the camera, it was useful for the model to say, oh, that's a hand, and then you could go and exclude it. So that's kind of why I've got those. And then you can go and train the model. I've already trained this model. Siri is piping up. And then I can go and do a quick test. and I'm going to go and browse to some fruit that I've got loaded up here. I'm going to load up this orange, and you can see it's come back and shown me that the orange is 100%. There's 100% sure the prediction is for this. Now, what I've also done is I've created a very simple application, which basically takes that model. So if I come over to the model, if I'll just close that, and I'll come over to performance, what I can do is I can export this model, and there's various formats. You can export into TensorFlow or Core ML if you want to go and build mobile applications. But I've exported this to a Docker container, and I can say this is a Linux Docker container. Now, what I've done is I've exported that, and I've built that container, and I'm running that container on a local system on my network at home. So what I'm going to do now is I've got a very simple application. This is available on my GitHub, and I've just selected the folder which has got the fruit in, and you can see, okay, so what I've done is that I've loaded up, in this case, an image of an orange, and you can see what it's done is it's called the container which is running the model, which is going to come back and say, I recognize this, it's an orange, and it's a very high probability of 1 or 100%. Same thing for banana, same thing for the green apple. And you can see the red apple, it's like 93%. I normally set like a threshold of 80% when I look if I'm going to trust this. Now you can see I threw in a photo of a building. In this case, it's thinking, well, it could be a banana, but like it's 63%. And as I said before, I would set a threshold of probably about 80% to 85, depending on how well the model's been trained.
Exactly. Yeah.
And you see, this is a caravan, and it thinks it's possibly a hand, but it's a very low probability of that being a hand. Now, I've shown this example here around fruit, but of course, this could be an example here where you might have images of cancer cells or images of tuberculosis or things like that. I'm not sure I picked that example, but I think, Priyanka, you had a great example of where you've been using these. Maybe you want to talk about that.
Right. Yeah. No, which is actually great, Dave. I was coming to that, right? So this image recognition, the practical use case of that we have seen in the times of pandemic, where computer algorithms, vision algorithms were used to auto isolate chest X-rays of affected patients, right? To automate the diagnosis during the pandemic time. So absolutely, that was one of the major, real-time applications of AI.
Yeah. So that is a fantastic way of getting up on board with that. Okay, Priyanka, I think you're going to switch over to your screen, and you're going to talk through
natural language
processing. And just be aware, we are running a little bit, about 3 or 4 minutes behind. So keep that in mind.
Yes, absolutely. Let me just quickly, do that. Yeah. So while Dave has taught us about applications that can see, now let's see applications of AI which would be helping us to talk and speak and recognize audio and text. Dave, is my setting correct? Am I in the presentation mode?
No, you're not. No, you're not.
Oh, that's
good call.
I'm so sorry. All right. Okay. Right. So when we talk of natural language processing, right, it basically focuses on advanced text and speech. So it is AI services for intelligent apps which will be able to caption speech to text. The real life example of that is, your YouTube subtitles or transcribing your audio to text in your Teams live transcription. Call center analytics, definitely when you have your call center calls, you get this message that we will be recording this for quality purposes. So that is where it transcribes your calls to better understand the quality of the call, the intent. Voice assistants, our Siris and Alexas and Googles, right? Text to speech, definitely. And then translation between different languages. So you can speak in Korean, but it might be translated in Japanese and so on and so forth. Okay, but the question lingers, right? That why do we need NLP? Because most of the data around us is unstructured. Our tweets, our reels, our Instagram feeds, and our audio messages, video clips, everything there out is unstructured. For a computer to make sense of it, it has to be computed in a way and broken down in a way that helps us understand, and make better decisions, improve decision making, right? And then it should be converted into a format which can be evaluated and processed by machines, because people use different languages, people have different ways of speaking, styles of speaking, we use different terminologies, right? So some of the techniques which are there out for NLP, they comprise of a range of tools. So which are the predominant ones are sentiment analysis, so blocking of your malicious tweets, and named entity recognition. Then you have text summarization, you have sentence completion, and all of these awesomeness is blended into our newest wave of AI, which is Gen AI. So all of these things like breaking down your parts of speech and knowledge graphs and everything is embedded nicely into all your large language models. So without much further ado, let me just quickly show you some of the uh, awesome demos around natural language processing. Okay, so let us quickly look at how natural language text is processed here. So let me for example search here for something. So this is a music demo what we are seeing here, and let me search for example who are the members of the Beatles. Okay, so when I do this, right, and it is now actually, so I have a lot of unstructured data out there, right, which are like music videos which we have scraped out from Wikipedia, music files. So the music files, they show us, that we have scraped genres, we have scraped artists, we have scraped their music. And when I ask a question to my bot, right, to my search bot, it is able to understand my question. It is able to actually search to the entire library of my documents, and then it is able to give me a targeted answer, right? And then I can also do a lot of other searches basically. So if I just go and if I search for anything else, you will be able to see the awesomeness of how natural language processing actually works here, where it is able to actually, so for example, now if I'm searching for Bob Marley there, right? And then it will give me all the documents which mention or are in some way related to Bob Marley. It will give me the genres in which he has performed, the albums in which he has performed, right? And then I can also do a very cool thing. And this is, by the way, the entity map is something which is not out of the box. This we have built custom for one of our clients, right? So you can see Bob Marley here, and then I'll be able to point out all the relationships which I have been able to extract from the documents. So I have the three aspects: artist, album, genre, out of which now I'm just selecting the number of artists which are directly related to Bob Marley, right, in some form or the other. So either they have collaborated, they have jointly performed at concerts, or jointly published something. And then I can also define level, like I want the artists who are very close related to Bob Marley, like a first order relationship, right? So yeah, so all these things, you can understand the complexities of NLP at work here, right? Able to extract entities and texts, and do all these fantastic things around your text documents, right? So yeah, so let us go back and learn a bit about knowledge mining as well, right? So once talked about NLP, one of the classic examples of NLP will be for doing knowledge mining. Hey, Dave, do you mind sharing back your screen? There's something wrong with my Teams. It seems it's hanging.
Yep, sure.
Yeah. So I have talked about the demo of NLP. I'll just run through knowledge mining, and I think then I'll hand over to you for responsible AI.
Okay, so you want me to be on?
Yeah, on knowledge mining.
Yep.
All right. Okay, so when we talk of knowledge mining, right, it is an upcoming discipline basically, which helps us to extract a lot of data from all these unstructured things, right? So the music demo which we saw, where we were able to actually extract a lot of information from so many things. Okay, so there were audio files and there were Wikipedia documents. Same way, knowledge mining helps us to extract all these things. And there are three pillars of knowledge mining. So you ingest the data from a variety of data sources out there: audio, video, images, text. Then you will enrich them, and then finally you will make it searchable in a way that users can actually harness the data, make some decisions, give out actionable insights. Okay, next slide, please.
That should have come up.
Okay, so what is the need for knowledge mining? Okay, so for knowledge mining, are you sharing your screen, Dave? Because I'm not able to see the screen.
Let me just double check. I was sharing my screen, but for some reason I'm not. Right.
Oh, all right. Yeah. Okay. So can you go back to the knowledge mining slide briefly?
Sure.
Yeah, so just, so these are the three pillars of knowledge mining. You're ingesting the data, you're enriching that, and you're making it ready to be explored, right? The way we explored it in our knowledge mining video music demo. Next slide, please. So what is the need for knowledge mining, right? So knowledge mining is basically needed because, as you see, we have a lot of data out there, and the capacity to analyze that data is humongous, and data is ever increasing. There is a data explosion, and which is why, we need all of these tools and techniques to be able to quickly break down our data and make it, in a manner which is available to be quickly searched and quickly, be harnessed to make business decisions, right? So which is why we have all these awesome knowledge mining tools out there: Azure Cognitive Searches and Cognitive Services Language Studio. So I encourage you to follow the tutorials to find out some of the most awesome details about the NLP techniques out there. And now that we have learned a bit about AI, there is a caveat, which how to use all of these tools and platforms responsibly. So I would pass it on to Dave to take us through responsible AI.
Okay, thanks, Priyanka. There was something I just wanted to point out in one of your demos. I think you might have said this, but I just want to go back. Now, one of those demos you showed was show me the members of the Beatles, I think was the query, wasn't it?
Yeah, that's right.
And one of the things I want to talk about in there was that you had, so you were using cognitive search.
Yes.
And you had semantic search enabled.
Yes, that's
now,
right.
What semantic search was doing is it understood the intent of your question.
Right.
So where we're going from is we're going from keyword search. So if that was keyword search, for example, you might end up with a whole lot of photos of Beatles. Just
That's
probably
right.
not what you meant.
Exactly.
See, the intent was, and it's looking at the intent and looking at understanding, say, okay, I want to find the members of the Beatles. So it's kind of understanding, okay, this is maybe a group. It's a group of Beatles. Okay, then maybe we're going to suggest that's probably going to be the pop group, the Beatles.
Absolutely.
When you did the Bob Marley, that was probably slightly more down the keyword lookup.
Yeah,
Was that
yeah,
fair?
yes, yeah. That's right. That's right.
Yeah. So super important to appreciate that there are a couple of things going on there. As that cognitive search is this amazing tool. You can upload all your documents and do it. It'll index it, and then you have this intent-based way in which you can go and search into that data and understand what is going on. Alrighty. Okay. So the last thing we're going to talk about, and then we've got Q&A section, is we just want to talk a bit about responsible AI.
Yeah.
So we've talked about AI, and no doubt you're reading in the paper or the press or wherever you're getting your news from, and you're probably getting two messages. There's, on one level, it's incredibly exciting, and the rate of change and the pace of innovation for AI at the moment is phenomenal. We're all talking about things like ChatGPT and AI and using AI inside our businesses. But they're also, but the really important thing to appreciate about AI, and particularly if you're building models, is that sometimes these AI models do not behave as intended. And in some cases, models can cause harm. And you'll no doubt have read about these cases. There were a lot of cases in the US, particularly around um, crime enforcement in the US, where you had potentially biased data that was being used to train models, which were then being used to try and predict maybe crime hotspots. The issue with that, of course, is you're taking human biases, and then you're reinforcing those biases inside AI machine learning models. And those are the kinds of things that we're all very concerned about. If you think about a lot of things in society today just aren't fair. It could be ways in which we apply for jobs. It could be criminal justice. It could be access to credit, a whole range of things like that, where there are a lot of societal biases in terms of access to those types of services and facilities. So to address these issues, Microsoft kicked off this initiative about 5 years ago, which was looking at something which we call responsible AI. And responsible AI is a way in which we're trying to address some of these issues around ways in which biases can work their way into models that we are training for our systems. So there are 6 basic principles, and you'll find a link down the bottom. There's a link down there. Just take a screenshot of this, or just go and search Microsoft Responsible AI. But they're just talking through some of these very briefly. We talk about privacy. So when we think about privacy, we think about privacy as a basic human right. So that we are very careful in the models that we train, and we encourage you that when you're training models, that you think about the privacy, making sure that data doesn't contain personal identification information. You need to think about where these models are running. Are they running in the cloud? Are they running on premise? Are they running on mobile? So who has access to these models and things like that. The next thing we talk about is inclusiveness. And the general emphasis is that you should be intentionally inclusive. Think about the total population that may be using these applications, and then think about those. Almost plan for your 3%. So for example, you might want to build a system that you want to make sure that people with visual impairments can use. So that might think about, okay, when I'm building these models, and I want to make sure when I'm building these applications which use them, I want to make sure that, for example, we're using speech to text for hearing impaired, or we want to use something like seeing AI or text. So we've got text to speech for visually impaired people, or be able to identify what the objects are in that environment. So things like that around inclusiveness. We want to make sure that models are fair. So we want to make sure that that models are reflecting the broad range of society. We want to make sure that we are transparent to model. We want to make sure we understand what the limitations of these AI models are. So then we're going to use them, we understand that, and we want to be able to understand what the behaviors are. So those are kind of, you'll find there are six principles, and I would actively encourage you to think about either building applications or building models or building applications which use these models. Make sure you understand all aspects of these models. Now, for training and building models, we have tools inside Azure machine learning. We have models in there for governance, for rules, for training, and we have tools and processes. So for example, if you're loading up a data set that you want to go and train these models on, there is something called the Responsible AI dashboard. And inside that dashboard, you can drill down into your data sets. And inside there, the data sets will say, well, hey, did you know that this part of your data is not fairly represented?
Yeah.
And that might be something you say, okay, well, maybe I need more data points to represent, I don't know, maybe the visual impaired community or something like that. Or you might say, well, actually, that's outside of the scope for that. That's fine, as long as you understand what the implications are of the models that you are using. Absolutely. Okay, so those are things that are really important. And there's some great tools. A lot of these tools are open source tools, and you'll find those all available in Azure Machine Learning as great ways to help with this process. It's probably not going to be perfect, but it's going to be a long way to helping with these. Now, what I want to flick across to is just show you where some of these resources are. So we go across to just search for responsible AI, Microsoft Responsible AI. It's an industry initiative. So you will find a lot of things there. So you'll find documentation on policy, management tools, guidelines. There is Explore Responsible AI resources. You'll find in here various tools in here for management. You'll find checklists. So here's, for example, an AI fairness checklist. Get the checklist, and you'll find very comprehensive documentation about the things that you should be thinking about for fairness. So the main thing I would actively encourage you, if you're building models or building applications which are using these models, that you do understand the implications of these. And Microsoft Responsible AI, as I said, it's an interesting initiative we kicked off 5 years ago when we started to understand the implications of using models and what that means. So I'd actively encourage you to go and check out all these resources here to help you building applications. Yeah. Okay, so finally we're up to knowledge check. So the first thing is in your browser, go to this link. The link is aka.ms/F. Now that is case sensitive. So you need to make sure you're using a capital F in here. And now the first question in here is going to be, you want to create a model to predict sales of ice cream based on historic data that includes daily ice cream sales totals and weather measurements. Which Azure service should you use? So the options are machine learning service. I don't know. What do you think? What do you think, Priyanka?
It would be nice for me to, just ask a bot and choose ice cream for me.
Yeah. Azure bot. Now that bot service, I've used the bot service before, and I've been able to ask a bot how many ice creams I'm beginning with. So I guess that could be, or language, because I need to be able to interpret sales totals and weather.
Yeah, I think it's a bit of all three, but let's see what our audience thinks there.
Okay. Well, we're giving it, so we're seeing voting, and there is convergence. Thank goodness, Priyanka. I think we've done well. I will just share it, so you should be able to see it on my screen. So there were 96% of you said that the answer is machine learning.
Well done, guys.
That's spot on. So remember, Priyanka showed that example of the weather conditions and bike rentals. Same idea. It could be house rent, it could be house prices, or whatever it is. It's using regression models, and that's how that's built. Okay, so Priyanka, this question is yours.
All right. So guys, the instructions remain the same. You just put the URL which you see at the bottom for you to vote. And then the question is, you're designing an AI application that uses images to detect cracks in car windshields and warn drivers when a windshield should be repaired or replaced. What AI workload is being described here? Is it computer vision? Is it anomaly detection? Or is it NLP, natural language processing? Well, I think, Dave, it resonates with the predictive maintenance example which you gave out there, right? Sort of alerts when something is not working, auto alerts. So I would probably lean towards anomaly detection. I'm not so sure.
Yeah, so hopefully you've gone to that URL and you're putting, okay, I can see people voting for that. It could be anomaly because I've got a crack in the glass screen, and that's not normal, but I've got computer vision. Computer vision, I don't know. I could be using vision to be able to detect the what's going on the screen and looking, using that
Yeah,
and using a model
actually, how
behind
do
that.
you know whether a screen is cracked, right? That is probably
Yeah.
where vision comes.
Natural language processing, look, I'm going to eliminate that one. Okay. So now, so I'm going to throw, we'll be able to look at the,
Yeah,
how people
so
voted for
yeah.
that. And 63%. Now, we did throw you off a little bit on this one. 63% did say computer vision, and that's probably what it would be. Now, in fairness, you could potentially, could you use anomaly detection? No, I think you'd really be using computer vision
Yes.
to be able to use it. So the answer is computer vision, but I have to say, we did deliberately try and throw you off using anomaly detection. Anomaly detection, you wouldn't really, you've got time series data, and that's what more computer vision. You've got a camera, you're looking at what's going on, and you've got models to look at. Yeah. Okay. So this is the third and final question. So we've got, and again, in your browser, a predictive app provides audio output for visually impaired users. Which principle of responsible AI is reflected here? Okay, so we've got transparency. So remember, transparency was more about what are the capabilities?
Yes.
Yeah, capabilities of this model. We've got inclusiveness. Yeah, okay, that could be one. And we've got fairness. Now, I don't know. What do you think, Priyanka?
I think this one is, it's a bit. I mean, this is a clear winner here, right? I know what to answer, but let's see what our audience thinks it is. I'm pretty sure this is what I think.
Yeah, so the votes are still coming in.
Yes.
Now, that would be predominantly around inclusiveness. So I gave the example before of making sure that you're thinking about your audiences. I think I particularly chose vision impaired. So that would be an example there of just thinking about the AI, the data sets that you're using, making sure they're inclusive to the population that's going to be using these models. So you're going to be using models to score. So, okay, so we're going to click on that. And the answer is indeed inclusiveness. All righty. So thank you for everybody for chiming in there. So that was great. Okay, so really, in summary, so hopefully you learned a couple of things about solutions that you can use AI to make possible. You remember there was building models. So we talked about machine learning services. And then we talked about really consuming models for application developers and consuming those models and then using those inside your business processes to go and do things, automate parts of your business processes. And without laboring the point, we did also learn about responsible AI. And again, I would thoroughly encourage you to go and check out responsible AI and best practices. Really important this day when people want to be confident about the use of AI and processes, and you need to have a good understanding what this AI is capable of. And what we tend to think about with AI, we tend to think about automate with AI and collaborate with AI. And you need to think about what are the risks for using AI in this. Can you automate it? It's low risk. Yep, I can automate it. Collaborate with AI. It's a higher risk. You want a human to be validating what is going on. Those are an example of a high level. Okay, so just reiterating, this session here was about get started with AI on Azure. And you'll find that there's a link at the bottom of this slide for aka.ms Learn at Build. And you can join a skills challenge. You can join a you can take your learning a whole step further with deep dives into Microsoft Learn collections, and there's a community that you can connect with. Okay, so we are finished with 1 minute over. So first of all, I would like to dearly thank Priyanka for being my gracious co-host today. So
loved it, absolutely.
Interesting. And what I love about Priyanka's an MVP. The MVP community as a passionate group, of passionate folk passionate about technology and making those technologies real for customer solutions. And that's where Priyanka provides huge value. So if you're wondering what the MVP community is about, that's what it's about. And finally, I would like to thank you all for joining in today. Hopefully you got something out of this. I believe the slides will probably be available. And feel free to ask questions, keep asking questions in the session, and we will do our best to answer questions at the end of the session. So thank you very much. Enjoy the rest of your day. And sorry, and go for it, Priyanka.
Yeah, that's what Dave. Thank you, Dave, and thank you to the audience as well.